I'm going to show you the service menu. This is what we use to configure the software to talk to the particular printer you're using. The printer configuration menu is where it all starts. This is only necessary if you're using our software to control a printer or to create G-codes. If you're just creating SLC files or if you're only using our software to fix files, you don't need to worry about this menu. Start by selecting a firmware, the firmware that your printer uses. The firmware is only necessary if you're actually controlling the printer directly from our software. If you're just creating G-codes, any of these firmwares create the same G-code. Then you want to enter the coordinates of your build bed center. So on our printer that's 0, 0, but on some printers 0, 0 is one of the corners. So the build bed center will be half of the maximum dimension in X and Y. Then you want to enter the bed temperature in degrees C. You can enter a different temperature for the raft and for the part, or you can have the same temperature. If you don't have a heated bed, you can just enter 0 or really any number and our software will ignore it. Next, you need to set up the communication timeouts. I recommend leaving these at the defaults. These numbers are all in seconds, and unless you're having some problem, these should work on any printer. If you get a timeout error from our software, then double the timeout and see what happens. Next is the extruder parameters. You want to start with the extruder temperature in degrees C. The extruder retraction distance is the amount that we withdraw the filament when we're doing a non-extrude move. So if we're moving from place to place but not actually extruding filament, we withdraw by this amount. 3 millimeters is fairly typical for most printers, but your drooling may vary. Then you can set the extruder retraction speed. This should be fairly fast, but if your printer is skipping steps, then you want to slow this down some. Filament density scale factor for the part is generally going to be around 1. If you think we're generating too much filament, you should make this number much less than 1. If you think we're generating not enough filament, you should make the number greater than 1. The amount of filament generated varies somewhat from software to software. So if you've used ScanForge, you may need this number to be a bit bigger. And if you've been using Slicer, you may need this number to be considerably smaller. It varies from one software to another. Filament density scaling factor for the first layer, you can make this number much larger, and that's what we do. Generally, the first layer you want to extrude some extra material in order to get good contact with your build plate. So that's where this number comes from. Finally, the speed, printer speed, all of these are in millimeters per minute, which is what the G-code reads. Printer speed while not extruding will generally be fairly high. Printer speed while extruding may be smaller, sometimes considerably smaller. It really depends on your printer. And then the printer speed while extruding the raft. This is actually the first layer. So whether you use a raft or not, the first layer is extruded at this speed. It can be the same as your printing speed, but generally you want it slower to get good adhesion to your raft. Good adhesion to your build plate. Next on the service menu is the port configuration. Again, this is only necessary if you're going to be generating G-codes or controlling the printer directly. So the first thing you want to do is decide what kind of connection. You can either write to a serial port or write to layer files. Let's take a look at layer files. So if you're going to use somebody else's software to communicate to the printer, you want to set this up. So you can save the layer files in the same directory the model, the STL file is in, or you can save them in a particular directory. You can see that we've got them saved in this directory. But it can be any directory on your computer. Then you can have some overwrite options. You can always overwrite the existing file, or it'll warn you if you're overwriting a file, and then you can change the file name. It always saves layers to a file called layers.txt. So you'll want to change that if you want to if you don't want to overwrite the files. Single multiple file options. Generally you want to have all the layer files in one file so that you can just send that directly to the printer. But we have the option of creating each layer in a separate file, which is useful to us for debugging. Then there's configure the serial port. If you're writing layer files, you don't need to configure the serial port, but if you're going to write to a serial port, you need to configure that. The port is whatever USB port you've got it connected to, your printer is connected to on your computer. Baud rate you'll generally want to be as high as possible. And generally parity, data bits, and stop bits are all these settings. This is a fairly typical setup. If you know that it's different, you can change it, but generally the defaults will work. Flow control can be either X on, X off, none, or hardware control. And that's that menu. Next is the build box dimensions. You just need to enter in millimeters the X, Y, and Z dimensions. You can change these, but if you change them, you have to restart the software to get the change to take effect. You can see that the build box here didn't change. If I restart the software, then you'll see the build box dimensions taking effect. You don't have to restart your computer. You don't have to reset your computer. You just need to close the software and reopen it. Finally, we've got the slicing parameters menu. Start with layer thickness. These dimensions are all in millimeters. Layer thickness, 1/4 of a millimeter is fairly typical, but whatever it is that you use is fine. Perimeter width compensation. This is basically the width of the filament you're extruding. So this may be, actually it's half the width of the filament you're extruding. So if you're creating something like an octopus where you don't really care what the dimensions are, you don't need to worry about this. But if you're creating a part that needs to fit into another part or interact with a bearing or a shaft, then this may be important to you. Spacing between perimeters is within the part, how much spacing do you need, and this is basically the width. So this will generally be twice the previous dimension. Spacing between inner perimeter and fills. So once you've created the perimeter, you're going to fill in the space in between, and this is a setting for how much overlap you want between the perimeter and the vectors that fill in the interior of the part. Then once you get away from the first few layers, the interior can be sparse. So you can change the spacing between fills. You can also print fewer fills. So instead of printing every single vector, you can print 1 of 5 or 1 of 4 or 1 of 3, 1 of 10, whatever you want that to be. And that determines the density of the interior of your part. Finally, there's the raft thickness and spacing. You can make a raft or not make a raft just by clicking that. First layer thickness. You'll generally want your first layer to be different than your other layers, and this is because when the printer wakes up, it's generally going to reset and be at 0, 0, 0. So you want this layer generally to be thin to compensate. Second layer thickness may be a little thicker than your standard layer thickness for your raft. And then you can have the first layer spacing and the second layer spacing be different. So the first layer can be very sparse just to get it established on the build bed. And then the second layer can be more dense. And these are, again, all dimensions are in millimeters. And that's it for the service menu. Hope you enjoy the software.